Hello everyone, welcome back to my channel. I am Ashutosh and today I am going to talk about two important aspects of MLOps, which are experiment tracking and model registry. So for that purpose, many or I would say most of the companies are using MLflow, which is an open source platform to manage end-to-end machine learning lifecycle, which includes experimentation, reproducibility, deployment and model versioning. So in this video, I am going to cover mainly the MLflow with the live demo, and the topics covers are as following. So let's start. So what is MLflow and its component? So MLflow is nothing but the open source platform to manage the ML lifecycle, which includes experimentation, reproducibility, deployment, and a central model registry, which is used for model versioning. Okay, I will explain later. So what MLflow offers? So MLflow offers four main components, that is MLflow tracking, projects, models, and model registry. So MLflow tracking is also known as model like experiment tracking. So what experiment exactly means? So see guys, when we train a machine learning model, we do different experiments, and that experiments could be related to different data set or different hyperparameter tuning, hyperparameters. So for example, we have a different set of parameters, and for each set of parameters we are creating a different model. We are training a different model, and then further we are analyzing for which set of parameter model is giving the optimal performance, and that those parameters we finalize. So that's the process of model tuning, right? So in model tuning phase we have different set of experiments. So the need is like we need to record or we need to store those experiments somewhere so that we can analyze them further. So for that purpose, MLflow offers MLflow tracking. Another is like MLflow project. So project is nothing but the like set of your complete code files, complete artifacts, which includes which are used to run the complete end-to-end machine learning model, right? Complete project. So it is the set of all required files. It's a simple, like it is like any other project. Another thing is like MLflow models. So MLflow model, let's understand after model registry. So what model registry is? Model registry helps you to track the different versions of your model. For example, you are doing different experiment in the step 1, and for each experiment you are getting one model. So that you need to register somewhere in the database so that you can check, okay, which model is performing better. So that's how we create different model versioning, and that for that purpose we use model registry. And then comes MLflow models. So now you have the model registry, like models is stored with you, and now you need to serve those model in the production so that they can predict something for whatever purpose they are designed, right? So for that purpose, like model serving, we use MLflow models, as it mentioned here, deploy machine learning models in diverse serving environments, right? So these are the four components MLflow offers. So today's video I am mainly focusing on MLflow tracking, that is experiment tracking, and model registry, because these are the most widely and most important components of MLflow. Okay, and in next videos I will be talking about model serving as well. So let's start. So guys, I'm going to show you the live demo of how to exactly record experiments and how to store or log your model. So please, I would suggest you also do along with me. So in all of my video, I like start with environment creation. So first thing first, let's create a Conda environment first. So how to create a Conda environment? So many of you might be knowing, but whoever is very new to this machine learning era, so for him mainly, you can use Conda environment, like Conda create -n, you can give your environment name, okay, and then whatever the version of Python you want to install. In this notebook I am using Python 3.9, and then of course you need to install IPY kernel. So using this command you can create an environment, and then you need to the moment environment is created, you can activate that environment using Conda activate environment name, and then you need to add that environment into your notebook as a kernel. Okay, so for that you can use this command. And then further inside that environment you need to install the notebook, so that you can open the Jupyter notebook from inside that environment. and then later you can install all the dependencies required like pandas, numpy, scikit-learn, imblearn, matplotlib, and MLflow. So these are mainly used for model training. So that part I will quickly cover because today's agenda is mainly to explain you the MLflow. Okay. So I'm hoping so you just install all these libraries and then install MLflow as well, and then from inside the environment itself you do Jupyter notebook and it will open the new notebook. So the moment you run this command from the terminal, what will happen? It will open something like this. Of course, you will not see anything here. It will open a blank if you are opening from the new folder or from whatever directory you are inside in your terminal. It will open that directory and it will show all of those files. So better create a fresh directory like project directory and then go to that directory in your terminal and then run these commands. Okay. So in that case, you will have a blank directory here. And now from here, if you see this new button, from here like your newly created environment will be visible here. So in my case, I'm using MLOps. In your case, whatever environment you have created, just click on that one and it will create a fresh new notebook. Okay. The moment you reach here, you are good to go ahead. Okay. So now let's start. So whatever code I am going to write further, you just execute here in this place. Okay. In your system. Fine. So let's do one by one. So another important thing guys, what I do basically just to double check from where my Python is being used, like from which path, either it is coming from the environment directory or it is coming from the system level or any other. So for that purpose, what you can do, you can import the system like sys and then print sys.executable. So this will tell you, okay, which directory your Python executable is coming from. So ideally it should come from your newly created environment. Okay. So just double check this. And then if you want to check the Python version, then of course you can run this line and it will tell you the installed Python version for that environment. I have used 3.9, so it is telling us, okay, 3.9.12 installed. Okay, so up to this, all environment setup and everything is done, and now you are ready with your fresh empty notebook. Now let's start the model training part quickly and then spend more time on understanding what is MLflow. Okay. So in model training, what we do, normally we import some libraries and we load our data. Okay, so I'm loading our data from this GitHub repository. This is my GitHub repository. Here I have uploaded this data set. You can also download or you can refer this URL directly. Or if you want to use any other data set, it's fine. You can use from your local system. Just load the data. So I've written this function. Okay, so I prefer to write the individual function for each step of model lifecycle, and then later call them. Okay, so it becomes a little easier. So it's up to you, like whatever the way you prefer. Okay, ultimately it is a code. So I have written a load data function, and inside that I'm reading the CSV from this directory. And then if let me run this, okay, so that you can also execute together with me. So it will import pandas, numpy, and then I'm loading the data from the, and then if you see it will show the like data.head. Data.head will show you the first 5 rows of the data set. So I'm using the diabetes data set basically. Sorry, I'm using the this banking data set. So banking data set has these many columns, and the idea is to predict whether the customer will opt for term deposit or not. Okay, so this is the data set. I'm assuming you guys are familiar with machine learning part. Okay, so I'm not spending much time here. I will spend more time to explain the MLflow part. Okay, and then if you want to do some data cleaning job, then you can use this function, and of course you can write further thing here. For example, outlier treatment or NA value, identifying NA values, removing NA values, distribution check, all sort of those data cleaning steps you can do here. And then we have some pre-processing steps, like I need to pre-process some of the columns like education column and then redefine with some new name. Okay, and then I'm handling the categorical variable here, right? So because categorical variable, like those are strings, and our machine learning won't understand the string part, so that's where we need to do something with respect to categorical variable. So here one way is like dummification. So we are creating the dummies for those categorical variable, and then once we got the dummy, then we'll remove the original variable because we already have the dummy columns for respective categorical variables, right? So that's what I'm doing here. And then in final data we have only dummy columns for categorical and rest of the columns. Okay, so now one more thing, like in some of the column names I have like dot presents, or then I'm replacing that with underscore, and if there is any space then I'm replacing that with underscore. Okay, so some sort of very basic pre-processing steps. So this is that part, and then for that data I'm splitting that into training and test part. Okay, so normal machine learning work, right? So we got xtrain, xtest, and ytrain, ytest, right? And then I've seen like this data is like very imbalanced with respect to the target class. So I'm using oversampling, like smooth technique for oversampling. So again, I'm initializing the object of smooth, that is oversampling, and then with respect to the target column, I will oversample it. Okay. So this also you can do, fine. You can execute. So let me execute, because later I will be calling these. Okay. So this is working code. I will give this notebook to you. Okay. Then just execute this part, train test split, fine. Then oversampling, this also fine. And then training basic classifier. So guys, in this video, I'm going to create two MLflow experiment. One is with basic classifier and one is with hyperparameter tuned one. Okay. So first I'm creating the basic classifier, the random forest one. Okay. I'm simply initializing the random forest classifier. I'm giving the estimator like 101. Okay. So it will create around 101 trees. Okay. And then model. So random forest is nothing but the set of decision trees, right? So for that one, and then fit xtrain, ytrain, and then it will give us the model back. Okay. And then I'm predicting on test data. So I'm passing the model and then test data, and then it will predict. So it will return the prediction result. And then if I'm interested in like predicting the probabilities, then we have predict proba function. Then you pass the x test, and model will predict the probabilities for that. Okay. And simply if I am interested in some metrics like what is the accuracy score, what is precision score, what is recall, and what is log loss, right? So from sklearn.metrics, import accuracy score, precision score, recall score, log loss, and then you can simply pass y true and y predicted value, and you can get this accuracy. So I am calculating this because I will just log in MLflow experiment, and I will show you like how to interpret them, right? So simply I'm creating some Python function to return all of this to us. And then I will be also interested to record some images like plots, like confusion matrix or ROC AUC plot. So I'm creating a function like create ROC AUC plot, and for that I need the classifier. Classifier is nothing but the model, and then x data, and then y data part. Okay. Like x data and y data, and for that here x data y data means like you can pass xtrain, ytrain, or x test, y test, any of them, right? So that this function is generic, and it will create a ROC AUC for those your training data and testing data, whatever you pass as a parameter. Okay. Matplotlib for that plotting, visualization library, and then sklearn metrics, and then metrics.plot ROC AUC curve, and you pass this parameter, it will return the PNG image for that, and it will save whatever directory you are in. Fine. Similarly, we can plot the confusion matrix, same library, matplotlib and sklearn, and then if you call this function plot confusion matrix, it will plot the confusion matrix for us using these parameters, right? So let me execute this part as well. So it will not produce any output because these are simply the function definition. I have not called yet. In a moment, I am going to call each one of them, and then it will give us the output as well. Okay. So I'm just quickly explaining what is happening inside the function. Now coming to hyperparameter tuning, as I said, like first I build the basic classifier. So this one, training basic classifier. So for this also I will create one experiment, and now I will tune the model to improve the performance, and then I will create experiment 2. Okay, so then I will show you what is the difference, basically how to interpret them inside MLflow UI. So that's the purpose. So I'm creating a method called hyperparameter tuning, and I'm passing the xtrain and ytrain, and here I'm defining the different parameters, set of parameters basically. So number of estimators like 5, 21, 20, 51, 101. So like number of trees in the random forest, right? How many trees it will form, and ultimately it will have the majority voting. So that's how random forest works. So here the idea is not to explain you random forest, just to quickly reach the MLflow point so that we can start understanding what is MLflow. Max features like how it will select the features like automatically, randomly, or squared, like the square root of the available features. Max depth, like the maximum number of levels allowed in each decision tree, right? And then maximum sample split, like minimum samples number to split a node, and then minimum sample leaf, like minimum sample number that can be stored in a leaf node, and bootstrap method used to sample data points, right? And then you just group them these inside a random grid. So I've created a random grid, and then I will pass that inside a random classifier. Then again I'm importing the library like Randomized Search CV. So this will be used for hyperparameter tuning, and then our random forest classifier. So let's initialize the classifier again, and then pass everything inside Randomized Search CV. So estimator, that is the model, classifier, param distributions, that is random grid, this one, right? And then this number of iterations, like how many iterations I want to run this, and cross validation, we score like 5 cross validation. Verbose, like what kind of output you want to see, like up to what depth, like every information what your model produce, or very high level information. You can remove this and check the output, you can include this and check the output, you can understand the difference clearly. And random state, like so that in each run it will take the same sample data, right? And number of jobs, link -1 means it will fully utilize the CPU, like all cores, and if one, no cores, right? So these are just some set of parameters. Importance are these things. And then model tuning, like model tuning, I created this object and then dot fit. Simply I'm training the model, and I got the trained model for this. Okay, so if you see, like if you print random grid, then it will print this complete thing. And if you print like base parameter, so model tuning will return the base set of parameter. Like it will run in iteration, like loops internally, randomized search CV, and for each loop it will check the model performance, and where in whichever combination of parameter model is performing better, like optimized one, it will return those as a like base parameter, and that you can get like dot base parameter underscore. Okay, so I have printed this. In a moment I'm going to run and I will show you. Okay, so base parameter like this, and then now you got the base parameter, and then you can train the final model with these base set of parameters. So again, random forest classifier, you just define those base set of parameter here, right? And if you quickly go back to our basic classifier, then here you see, like I have not given any set of parameter. Where it went? Basically, yeah, this one. Simply I have defined number of estimators, like 101, no other parameter. So it's a very basic classifier. Okay, we'll see how much accuracy this is giving. Okay, and then we tuned the model, like tuned the hyperparameter, and then we are getting the tuned model, this one, model tuned, right? And base parameter. So we have basic classifier, we have tuned model, right? So till now we have created all the functions. Now it's time to call one by one and see the what kind of output we are getting. Okay, so let me execute this quickly. So now function definition is done. Let me load the data. So this is fine. Let me quickly do the cleaning also. So cleaning, like no NA values available in data set. Okay, and we have dropped. So after dropping also, of course, no NA values, so no sense of dropping them. Okay, but for the like completion of this notebook, I have included everything. Okay, so pre-processing, you can simply call. So pre-processing happened, and then we got the xtrain, xtest, ytrain, ytest with us. Okay, and then we have to call oversampling. So this is also done. Like length of oversample data is like 51,000. So number of subscription in oversample data like 25,000, and subscription 25. Like no subscription and subscription both are equal. But before oversampling, if you check the same thing, so data was imbalanced. Okay, so now this is oversampling. So this is a machine learning concept, guys. So I'm not going to spend much time on that part. That's fine. Okay, so let's quickly reach towards the MLflow part. So again, as I said, like I will be training two models. Like one is basic classifier and one is like that one tuned one, right? Hyperparameter tuned one. So you call the training basic classifier with the xtrain and ytrain data set. You will get the model. Okay, so let me execute this as well. So now we have a model with us, and if you run this predict on test model, then you need to pass the model and the testing variables, testing data, then you will get the predicted. So if I print this ypred, y underscore pred, then you will see the array of predicted values. Okay, and then if you run this one, then it will give you the array of predicted probabilities. So let me quickly print this as well. So here you see the probabilities, like 96% probabilities for belonging to class 1 and only 3% belonging to class 0, like that. Okay, and then run matrix. So run matrix, if I print this again, then it will give you all those precision, recall everything. See, so we are getting with basic classifier, even we are getting 91% accuracy, and precision rate is 62%, and recall is 51%. Very less, right? So because till now we have not sampled yet, and we have trained the basic classifier, and we are getting a very less recall and precision, and accuracy is fine, 91%. Whenever we have imbalanced class problem, then we simply prefer to check the precision recall, right? You can refer my other videos where I have explained clearly like when to use precision, when to use recall, when to use accuracy, right? So you can get the link in the description. Again, now I want to record create ROC AUC plot as well. Okay, so if I run this one, so it will create ROC AUC plot, so with area under curve is 94. Okay, and similarly if I run the confusion matrix, it will plot the confusion matrix also. So now guys, you see like these are the artifacts, these are the plots, right? And you want to record somewhere so that later you can refer like, okay, for that particular version of model, what was the confusion matrix, what was the accuracy score, what was the ROC AUC curve, or what are the experiments, what are the runs, everything, right? So for that purpose we will be using MLflow. So till this point I have explained very quickly like how to train your model, how to train basic classifier, how to train the tuned one, and now MLflow work is going to start. Okay, so now for that, so the what are the goal, what is the objective? We have created two model, one is basic classifier and one is like tuned one, and we want to record those experiments. Okay, so let's do step by step. So as I said, I want to record the experiments. I will be creating an experiment name, so let's give a name as experiment_1. okay, and then a run name. So what is run basically, guys? So experiment is nothing but like when you have some set of parameters, or you are training a very basic model without any set of parameter, like very basic one, like just number of estimators which we have given, right? And you created experiment. Now when you are executing that experiment, then it creates a run. Run is like a particular instance of that experiment. Okay, so like the in execution, so that's where I have defined run as term deposit. You can give any, so term deposit nothing but related to our model problem, right? So we want to predict like whether a person will subscribe for term deposit or not, right? So you can give any name, any meaningful name, right? And then I'm calling run matrix, and then simply printing the run matrix. So here is fine. So I will record these things in our experiment. Okay, so how you can do, you can call the create experiment. So I will explain what is there inside the create experiment. So this is here. So I will pass the experiment name, I will pass the run name which I have defined here, right? And then I will pass the run matrix, because this I want to record for later purposes, and I want to record this model as well. Okay, and I want to record the confusion matrix.png which I have created here, right? Create confusion matrix. If you go to this function create confusion matrix, then here you see like I have already explained the definitions, right? So create confusion matrix, so like it is plotting this confusion matrix, and plt.save, I'm saving this, it will save in the same directory. Okay, so let me go there. So confusion matrix and then ROC AUC curve.png. okay, so these things I want to record. So this create experiment will call nothing but this method. Okay, so these are the parameter I'm expecting. Okay, so now here experiment name is must, run name is must, some matrix. This also you can make it null, but it will not record anything. But if you're simply creating experiment without having anything, it doesn't make any sense, right? So at least I'm recording some matrix, like performance matrix you will be having. At least for basic classifier we don't have many hyperparameters, then still you will have some performance score, right? So run matrix, and then model you will have, and all other like I have made it optional, right? You might want to record the confusion matrix or not, so none. Okay, ROC AUC plot none. So if you will pass that, it will take care. If you not pass that, it will take it as none. And similarly run parameters. Okay, so like if you have some hyperparameter used in the model, then you can record them. If you have not used them, then you will not record them. Okay, so first time I'm recording the basic classifier. Let me write it like basic classifier. Okay, it's like that. So maybe I can give this also name basic underscore classifier. Okay, basic classifier. So I'm recording experiment for that one. Okay, and now let me explain this code, okay, in detail. So what I'm doing, I'm importing MLflow. You have already installed, and then if you do MLflow.set experiment and you pass the experiment name which is coming from here, right, then it will create the experiment, and then you want to start MLflow.start run. Okay, and then you can check like so these are the good practices basically if you are checking it for none or not, otherwise you can directly do this thing. Okay, so these are the coding practice. So let's do that one. If not, run parameter is equal to none, then it will go inside. If it is none, then it will not go inside, right? So run parameter is like here in this particular one, the basic classifier, it is none, so it will not go inside. But in next part, which I am going to explain, there I will pass in the dictionary. Okay, so that's where we can iterate it. So log parameter, so each parameter it will record. So let's first go through the run matrix, then I will explain run parameter in next one. So for metrics in run matrix, okay, so run matrix I am passing this. You see here we have accuracy, we have precision, we have recall, we have entropy, right? So for each of them it will iterate and it will record. So in first loop it will record accuracy as a 91%, then second it will record again precision as a 62 and recall as a 51, entropy as 0.2, right? So this is simple loop. And then we want to record the model also, then MLflow.sklearn, because it is a scikit-learn model. You can use TensorFlow, you can use PyTorch or any other environment like platform, right? So it is a platform agnostic, you can use any framework of model. Okay, so like that you can record the model. So like model is coming from here and you can give like model. So you can name as logistic regression model, random forest model, whatever model you are used. Okay, you can give them a name. And then I am recording the confusion matrix also. Okay, so if we have the plot available with us, we can log that one. So how we can do MLflow.log artifact, and you can give confusion matrix path, and then you can name it like this is confusion matrix. You can pass the PNG one. Okay, and similarly ROC plot. Okay, so log artifact it will. So as I said, artifact. So if you want to record or store any file or any image, you can use artifacts. So inside artifact you can log these things. Okay, and then you can also do some tagging. For example, you have maybe 50 or 100 experiments recorded and you want to search that one, then you can do the tagging, and with that tag you can search that particular experiment, right? So you can so here I have shown like you can record one tag, or if you have multiple then you can use tags. So tag 2 like this one, tag 3 like production. So later in future if you want to search this particular experiment, you can search with these tags. Okay, and then I'm just simply printing like log to experiment and then run name and experiment. So this run is logged in this experiment. Okay, so let me quickly run this and then I will show you the magic what happens. Okay, so now this function definition is created. Now let me quickly call this one. So before calling this one, it will change directory structure a little bit. So let me go through again back to this one. Okay, so here you see we have MLflow live demo. In your case you have newly created files, these two will be there. And now see 7 minutes ago just now we have created this confusion matrix.plot, like so same thing is created here. And similarly like MLflow.png is created. So this anyway I'm using this one, not I was telling this ROC curve PNG is created here, right? So now this I want to store as an artifact inside MLflow. So this is anyway your local directory. I'm going to record everything inside MLflow. Okay, so here you see only these things is available. Okay, and you can see look into your folder. And now the moment I'm going to run this, it will create some more folders. For example, ML runs. Okay, so let me create this. So now see it is telling experiment with name experiment 1 does not experiment 1. Okay, so I'm passing. Okay, so I have not ran that one after changing. So where is experiment? Okay, so this I updated this, right? Before it was experiment 1. I updated this, so I need to run this again. So if I run this again, then if I run this again, then it will log here basic classifier. So it is with the name basic classifier does not exist, creating a new experiment. Okay, so run term deposit is logged to experiment basic classifier, right? So till now you have recorded the basic classifier in your MLflow UI, but how to start that UI, right? So for that purpose what you can do, from inside the Anaconda you can open an Anaconda prompt. So let me open a new Anaconda prompt freshly. Okay, and I will go to that folder like where I am doing this documents, projects, MLflow. Okay, and let me activate the environment so that it gets all the dependencies. Okay, now you see this base is changed to MLOps. Okay, so now from here I need to do MLflow UI. If I run this MLflow UI, then it will open the MLflow UI in localhost. Okay, so quickly it will do this, so I can open this URL, okay, in the new tab. So now you see here, so experiment 1 by mistake I had created, so this has 1 minute ago, right, it has logged that one. So content wise both will be same, just the different names. So let me go through this one. Okay, so here basic classifier is recorded with metrics, so accuracy, entropy, precision, right, and then tags, these are some tags. Okay, and if you go inside this one, guys, then here you see, like, I have not recorded any experiment. You can edit the description. I have not recorded any parameters because we have not tuned. It was a very basic model, right? So I have not recorded any parameters. I have recorded metrics. So you see here, like accuracy 0.91, entropy 0.2, everything is coming. You have also recorded the tags. So we have tags here. You can also add tags from here as well. Okay, and then we have some artifacts recorded. So like you see, like we have confusion matrix, you can see here, and we have model recorded with us, like model.pickle file, and then environment.yaml. So if you are using this, then they will be used for automatically conda environment creation, or we have the dependencies listed in as a text file also. If you want to use pip install, then you can use pip install this requirement.txt file. Okay, and then we have this ROCAUC plot available with us. So like as I said, these files, models, or any other file, maybe you want to record some small data set or any their file, right, you can use inside the artifacts, right? So we have model with us. Now you can register this model. Okay, so before registering this model, let me show some more things. Okay, so if you go to experiment, so we have this experiment, and now if I run this command again, okay, without changing the experiment name, so what it will do, it will not create any new experiment, but it will create a new run under that experiment. So let me run this. I ran this again, so just a minute. Okay, so run term deposit is logged to experiment basic classifier, same one, because that existed. So now if I can go here, I refresh this, see, 12 seconds ago, so new run has been created with same detail, because parametrics, because I have not changed any parameters, it will give the same metrics. But what you can also do, you can just change some of the parameter, you can again train the model, and then again register the new run under the same experiment. So how many times you run this, those many experiments will be recorded. Okay, you keep on running this, it will keep on recording new experiment. Okay, and you go here, go to experiments and just do a refresh and come under here. See, these many experiments are recorded, right? So of course metrics values will be same, because I have not done any change in the classifier. If you change the parameters, then these values will also be changed, which I am going to show in a moment. Okay, so before that I just wanted to show you some more things. So like now you see here, ML runs 4 minutes ago. So this newly created folder, so what this includes, it will include all your experiments. We, as of now, we have 2 experiments, experiment 1 and basic classifier, right? So if you go here, then so this is just simple YAML file with some like dependency, all those things, like the path and all those things. Okay, so this is of no important. You can simply go to other, like this first experiment, this second experiment. So this is experiment 1, and under that we have these artifacts. So like everything, like tags are there. So like the tag 1 random forest, you can click and open. Okay, so basically this is the storage area, but the better visualization is this one. Okay, but I just simply want to show you, like you get everything here. Okay, like this, and then if you go to parameter, we don't have anything in parameter, metrics we have all accuracy and everything, it will be okay. It's okay. So this is the storage. So we are storing everything as a file, guys. Okay, so I will also show you how to record those experiments as a database, as a backend database. Okay, so hold on, one more thing I will explain. Okay, no worries. So now quickly go back, come here. Right. So See, as I said, it is a platform agnostic, it is a framework agnostic. So you simply create this MLN and you can shift this complete artifact in your production environment, and from there it will serve the model, because inside artifacts you will have model also. See, this is model.pickle file is available. Okay, so from here you can pick that model. So that also I will show as part of model serving. Okay, so everything I will explain, no worries. Okay, so but for time being you just understand, okay, we have created different experiments which are stored as a file system inside this MLrun registry, inside this MLrun folder. Okay, now, so whatever we have done till now, it was with respect to basic classifier. Now let's do this record another experiment with the tuned one, right? So we have also tuned the model. So here you see hyperparameter tuning, right? And we have created another model, like model tuned with based parameter, right? So let me create another experiment with tuned one, right? So but before that we need to call that tuning, right? So here I am creating the experiment 2 as model maybe optimized model. Model anyway, let it be small only, optimized model. Okay, and then run name I am given random search CV tuned model. Okay, we are using randomized search CV, and then hyperparameter tuning, the same method I am calling, which I have explained a bit earlier, and then I am passing xtrain and ytrain because we are training the model, and then it will return the base set of parameter also. This function is returning two parameter. One is model and one is based parameter, right? So if you have any confusion, you can just go back to the video and you can watch it again. Okay, no problem. So we have based parameter, and now what we can do, we can predict on test data. So you just need to pass the model tuned and xtest. So here if you see, here I was doing the same thing, but I was passing the default classifier, like basic model. See, here we are passing the default class, that the basic model, but here I am passing the tuned model, right? And then if you want to have the probability, then you can pass the same thing, tuned model, and then get the matrix. Okay, so let me quickly run this. Okay, so it is training the model. It will take a bit time, maybe 1 minute or 2 minutes, because it will do all the iteration and come up with the base set of parameters. Okay, so let it do it quickly. So if you see your command prompt, Anaconda prompt, where you have opened this notebook, then you see these things are executing. So step by step log it will show. Yeah, so now it has completed. So if I go back, so here you see, so fitting 5 folds for each of 100 candidate, totaling 500, fine, and then random. So here so if you go to this function, so I have printed random grid and based parameter. So where it is, you can always go back, this hyperparameter tuning, and then see these two things I have printed, right? So now these two things are printed as output. So I can go back, let's see. So here, so random grid, so these are the parameter we have initialized to tune the model, and then I got the base set of parameter. What is this meaning based parameter? So in number of estimator, I have given these options 5, 21, 51, 101. I have given odd number so that because when we do the majority voting, so there should not be any conflict. So that's where I have given. So for 101, it is giving us optimal performance with other set min sample split. Where is min sample split? This. So for that 10 min sample leave, 4 max features, that is auto, and then max depth it is taking as a 50, that is 50, and bootstrap true. Okay, so now we'll get the final model on these based parameters. Okay, so we have got, and then we have got the run matrix also. If I print those run matrix, then you will see the optimal one, accuracy 91, precision the 61, and recall 57. Okay, so now this, of course there is still a chance to improve this model. As I said, my goal is not to optimize the model, but to show you the set of steps which are included to use the MLflow as a model experiment tracking and model registry. Okay, so you can further tune your model if you are not happy with this performance, but let's go ahead with this performance. Okay, and let's record this model. That's the objective. So now if you just run this, then you will find this. Okay, so these are the base set of parameters, and now again I'm calling the same experiment. So this method, so that's where, guys, I created this function and I can call it again and again. So that's where I was telling, okay, create a generic function, you can call it again and again. That's the use of this functioning. Create experiment with experiment name. So what experiment name I'm giving here, like optimized model with run this. Okay, run name. Run metrics. So these metrics will be recorded this time. Then model tuned. So whatever model I got as a hyperparameter tuning, this model tuned, and then base parameter I'm passing. Okay, like base parameter I'm assigning to run parameters. Again here this, so run parameter I'm passing. You can pass directly this also, not a problem, right? So model tuned, and then confusion matrix, then ROC AUC, and then run parameter. So this run parameter is a new thing which I am passing this time. Run parameter I have not passed in basic classifier because we didn't have any run parameter, right? Here I am not passing any run parameter. So that's where you see here it has not recorded any parameter. So parameter section is blank, right? But now this time whatever experiment I am recording, so it will have the parameter value as well. Okay. So now let's see. So let me call this experiment again and let's see what it does. So experiment with name optimized model does not exist. So that's where it is creating the new experiment. But if it exists already, then it will create the new run under that one. Okay. So now it has run. Now if I refresh this, guys, okay. So see here, optimized model is created just now and with one run value. So here if you go here, so we have metrics assigned, we have these parameters assigned like bootstrap value, max depth, max feature, and then tags, everything else other thing. Okay, let's go inside that one. See here, you see we have recorded. So these are the 10 optimal set of hyperparameters which I have used for model tuning, and then for this set of parameter I am getting these values. You just change this parameter value, you will get different set of model performance metrics, and that will be treated as a new run or new experiment. Okay, and then we have these tags, tag 1, tag 2. These are used for model like searching the experiment if in future you have lot of experiments. Okay, and then again confusion matrix as an artifact is recorded here, and then model is recorded here. Okay, and then so now guys, one more thing. Now you have recorded your experiment and you have a model and everything available with you. So what is the use of this? So like this, in this registry you have everything needed for that serving model in production. So you just simply give this folder, packaged folder to your DevOps, and they will take care of model deployment easily, right? So that's the advantage of this MLflow. Now guys, let's again run this second time. Then you will see the experiments. It has this time it has not created any experiment newly because experiment already existed. It has simply logged the new run. See, if I go here and go back and run this, refresh it, then you see new experiment got recorded, right? Of course you can change the run name. Sorry, this is not new experiment. Under that experiment, new run. Okay, so showing 2 matching runs. Okay, with same thing. And you keep on running this, it will keep on adding new runs. Okay, you keep on changing these parameter and you can keep on running. Okay, so I hope till this point is clear, guys. Now you see one more thing, guys, important thing. Everything is getting recorded under this ML run. So now we have 3 experiment, 1, 2, 3. So this 01 is simple YAML file with some configuration settings. Okay, this is experiment 1. Then this is experiment with basic classifier. Then this is experiment with optimized classifier. Okay, optimized one. Okay, and these are the artifacts. So everything needed for that model to run, to serve model in production, everything we have here. Okay, so that how model will be used for serving, I will cover it next video. But in this video, let me cover the complete basics. There are still some concepts are remaining. Let me go there. Okay, so after this, like how to utilize this artifact for model serving, I will talk later. Okay. So now again coming back here. So guys, another important remaining thing is here for concept building is like the model registry backend storage. So here I am utilizing the file as a backend storage. But what if you want to use as some database as a backend storage? Okay. For that purpose, what we can use, for example, if we want to use the model registry feature, we need a database. What this means? See here. If you come here and if you click in models, it will give error. See, this model registry functionality is unavailable, got unsupported URI ML runs, because file type as a model storage is not supported in this model registry. Okay, so for that purpose we need to use one of the database. Okay, so if you want to use MySQL, then install MySQL in your local and then create a database inside that MySQL. Okay, you can give any name here like this. Okay, and then like in the terminal I have started MLflow using MLflow UI, right? So instead of that MLflow UI, what you can do, you can use this URL MLflow. I will show the demo as well. Let me explain. So you can use MLflow server, and then you can pass these arguments like backend storage URI. What is the URL for backend storage? You can give MySQL and then root, user and then your localhost and then MLflow tracking database. So this tracking database is nothing but this one database name, and default artifact root, you can define the artifact root here. So like run. Okay, and then you can define this 000 host name and then port as 5000. And after executing this command, what you need to do, you need to set the tracking URI also. So this could be your local host and this could be your any remote URL where MLflow is hosted. Okay, so in my system I have not installed MySQL. I will just show you the demo with SQLite. Okay, because that is installed, but the steps are same, guys. I have given you the command what you can do. So let's do this same thing with SQLite. So for that, what you can do, instead of this command, I need to run this command. Okay, this command. So let me open the command prompt quickly. Just give me a minute. Okay, yeah, so here it was running. So let me stop this using Control C. It aborted. Okay, and now I need to run this line of code. Let me copy this, and guys, see here it will create a new artifact directory here. Okay, and it will create a MLflow.db automatically inside SQLite. Here we have to create this, and here it will take care of everything here. So here you see there is no MLflow.db. The moment I run that command, it will create here. So let me execute that command. So let me copy this first. Okay, so MLflow server and backend storage URL is SQLite. And then this. Let me execute this. Okay, so it will run. Okay, it is serving at this point. Okay, and now next step we need to define this MLflow tracking URL. So inside experiment tracking, what I will do, I need to define this. So this experiment, so I'll do little change here. That's it. Okay, and then I will run this part again. So that definition is changed. Okay, and now yeah, so that's it. So now if I go to that URL again, so local, I'm serving still in localhost. See, in localhost. Okay, and that is mapped to SQLite as a backend store. So now if see, let me, before creating experiment, let me show you this thing. Okay, here you don't have any experiment because now it is referring to SQLite as a backend storage, not the file one. So previously recorded experiment existed in the ML run folder, that is a file repository. But now I am referring to backend store as see here, right? So backend, you ran this, right? Backend store as SQLite. So and inside that I have not created any experiment anyway, which I am going to create. So that's where it is showing blank. Now you see, now you come here and run this command again. Okay, so it will create. Okay. Okay, so you got that error because here I pasted this line here. I pasted it here. So that's where it was trying to create the experiment, but till now it was not able to map to that database, right? So that's where you need to paste this line before. So please keep that in mind. Okay, so you just need to rerun that line, that because you have changed this definition, right? So you need to rerun that chunk of code, that function, and then again if you call this one, then it will work. Okay, So I have already ran, so it is telling optimized model does not exist, because now I'm using the backend store as a SQLite. So again it is trying to create the freshly, right? So that's why it is still does not exist. But now if I run this again, it will simply create the new run under that experiment. It will not create new experiment, right? See, now if I see here, I'll refresh, then it will show it here as well. See, optimized model came here, and see there are two experiments just now created 1 minute ago and 9 seconds ago, right? And with all set of parameter recorded. Now let's understand little bit more about this experiment. So we have recorded this optimized model experiment, and under that two runs are recorded, and you go here. So guys, the use of this experiment tracking is like in future, like you do multiple experiment, and now when it comes to comparison, how you'll compare, you need to store somewhere, right? So that's where MLflow provides a very nice look and feel UI, where you can register all the parameters, all your metrics, all your tags, and all your artifacts, right? And then you can easily do the comparatively analysis, like which experiment, which set of parameters are doing better to give you the optimized model, right? So now this you understood. Now the next thing is like, what is this register model and what is this model prediction? So this is, guys, this is helpful in model serving. So as if I go at the very top here, so here I was explaining like 4 important components. So I shown you, like I explained model tracking, that is nothing but the experiment tracking, how to record an experiment, parameters, log, metrics, images, everything, how to store your model inside model registry. So I have shown you like as a file system, as a SQLite DB also. You can replace SQLite DB with any other database, okay? And now MLflow model. So MLflow projects is nothing but you group everything and create a project like all the set of files together. Then that will become MLflow project. So this is nothing new, right? This is normal. MLflow model. So this is like when it comes to model serving in production. So that's where this line of code will be helpful. So this, guys, I'm going to explain in my next video. Otherwise this video length will be too long. Okay. Let me quickly cover this also. So you can register. Suppose you are happy with this model performance. You check these values and you are happy with that one. Okay. And you want to register that model for production. You can do using that one. You can create a new model. Okay. For example, prod_model. And then you can register it, okay, and then you can go there and it will be visible under model section, okay. So it has created a run ID for that one, okay, and it will have everything blank as of now because we have not created, we've simply registered the model, we have not deployed yet, guys, okay. So for that, see, version 1 is created and it is staging like none, we have not deployed yet, right? So we need to deploy that model. So for that, so like see here is staging, like from staging, from production, or you can also do the archived part, okay. So how to do this thing, model deployment and model serving, this, guys, I'm going to cover in this video. So for today's agenda, today's topic, I think everything I have completed, and also like I will share this notebook, okay, so you can execute together, execute in your local system, okay, and just see if you have any doubt, then please contact me using the comment section. I will like try to reply. I mean, I will reply normally I reply every comment, okay. As the next steps, I will be covering the MLflow, how to deploy models from model registry, model serving, both batch serving and online serving, MLflow pipelines. Yeah, this is also important aspects of MLflow, that is the pipeline. It has the functionality to create the pipelines, which are very, very important in MLflow lifecycle. Then model validation, okay, so how to do the model validation basically, okay. So this I will be explaining as a next video, so that will be, I mean, very shortly it will be available. So guys, that's it for today's video. I hope you enjoyed and you also executed everything along with me. So thanks for that, and please don't forget to like this video. That really helps me, okay, and that motivates me in creating new videos, okay. And of course, while I create new videos, I learn a lot. So also thanks for that, and yeah, thank you, and please don't forget to like, subscribe and share with your colleagues.